Okay, hopefully now you feel comfortable on how to count atoms. We're going to use that information when we get into chemical equations because you have to count the atoms to show that matter is being conserved. But let's get started with what a chemical equation is. Chemical equations, as you see here, show how matter acts during a reaction. There are two parts to a chemical reaction or chemical equation. There is the left-hand side and the right-hand side. The left-hand side, over here, is known as the reactants, the stuff at the beginning. It's always on the left. It's the stuff that you put in before the reaction occurs, also known as the ingredients. The stuff on the right are the products, or the stuff at the end, after the stuff is reacted. Okay? So it's the product, stuff that you've made, and it's always on the right. Okay, so here we have an equation written out. 2 H2O2 molecules yields, that's what this arrow means, 2 water and 1 oxygen. This is the equation we used when we had the foam models. The number of atoms that we start with must equal the number of atoms we end with. Now, if you were counting atoms, you will see that you have before the coefficient, so ignore the coefficient for right now, we have 2 hydrogen, 2 oxygen, but since we have 2 molecules of that, we distribute the 2 to both of these subscripts, so I have 2 times 2 hydrogen, or 4 hydrogen, and 2 times 2 oxygen, or 4 oxygen, so 4 hydrogen, 4 oxygen. That's going to yield 2 times 2 hydrogen here, that's 4 hydrogen, 2 times 1 oxygen, that gives us 2, plus another 2 oxygen, so a total of 4 oxygens. 4 hydrogen, 4 hydrogen, 4 oxygen, 4 oxygen. Okay, the number of atoms we started with equals the number of atoms we end with. Alright, so let's get into balancing equations. Next page. Alright, balancing equations. This is how you do it. First thing you do is you get your unbalanced equation, more than likely it's unbalanced, and you are going to list the elements under the arrow starting with metals. Okay, so you're going to start with your metals. Sodium is my most metallic, so I put some sodium there. Then I list nonmetals that aren't carbon, hydrogen, or oxygen. My only nonmetal that's not one of those is chlorine, so I put it there. Then I do carbon, hydrogen, and oxygen if I have them in that order. In this case, I only have hydrogen and oxygen. That's why it's H then O. Count the atoms of each element on both sides, and then record them next to the symbols. So, I look over here for sodium. I only have 1 sodium here, so I would write, get my pen out, I'd write 1 over here. On this side also, I look for my chlorine. I have 1 chlorine, write that here. Hydrogen, I have 1 hydrogen here, and I have 1 hydrogen here, so I have a total of 2 on the left-hand side. Total of 2 in my reactants. And I have 1 oxygen. Alright, so now I go over this side. Look at my sodium, 1 of them. Chlorine, 1 of them. Hydrogen, 2 of them. And oxygen, 1 of them. Okay? Now, if your numbers aren't the same, you're going to use coefficients only until you have the same amount of each element on both sides. In this case, we do not need to add any coefficients because there's understood 1s here. Okay? If there's no coefficient, it's understood to be a 1. And we don't need to add them because if you look, everything is the same. So this is a balanced equation already. Okay? Let's move on to the next page. There are some shortcuts or hints that'll make life a little bit easier for you. Okay? So instead of separating out a polyatomic ion into the different elements that make it up, if you see that polyatomic ion on both the reactant side and the product side, put the parentheses around it and keep it as its own, almost like it's its own element. Okay? So you'd write it all out down here as that. Okay? As long as it's on both sides, it acts as almost like its own element. Okay? And then you can count from there. If you see water, you can change that to H and OH. OH is a polyatomic ion of hydroxide. Or you could just make it H's and O's. That might be easier for some people. This is rarely used, okay? This is for tough problems that I'll give. If it starts to seem that it's impossible, like you can't get the number, and you think that if you made something like half of something, you can do that, but you can never have half an atom or half a molecule. So what you would have to do is, if you made one molecule a 0.5 or 2.5 or anything with a 0.5, and at the end you have to multiply everything by 2. I really don't expect us to have to use this. I probably will put something like this on an assessment, and it's going to be one of those harder questions. So if you really get it, then you'll get this one. And this is the difference between like a 90 and a 100 or a 95 and a 100. Doesn't mean that you won't do well on any sort of assessment without being able to do this way. Okay, this is just something that's more advanced. All right, let's move on. Okay, so here we go. It says to balance the following equation so that there are some numbers of molecules on each side of the yield sign. And it says clone the molecules as needed. I already did so. Move the answer box to reveal the answer. What numbers should be added to the equations, if any? So let's go through it. Well, we'll go through what we need to know. First thing first. Write down any metals. HO, HO. No metals. Non-metals that aren't carbon, hydrogen, oxygen. None here. And then carbon, hydrogen, oxygen in that order. There's no carbon, so you put hydrogen. And then oxygen, and you write this right underneath the arrow, okay? Count your number of hydrogens on the left, 2. Number of oxygens on your left or your reactant side, 2. Number of hydrogens on this side, 2. Oh, it's looking so easy until now. Oxygens, 1 and 2, so there's 3. So we aren't balanced right now. We have to balance them. Now to make this easier, I have actually put the different molecules here. Okay, this is the one we did in class with the models. So let's see what happens if I try to get more oxygens. So over here we have the right number of hydrogens. We need a different number of oxygens. So if I took 2 of these, okay, and I took 2 of these, and we count how many gray and red ones we have. Grays are the hydrogens. I have 1, 2, 3, 4. Okay, and I'll put that, since I have 2 of them, I'm going to put 2 here. Okay, so I now have 4 of these. I cross this out and I write the 4 next to it. And yes, cross it out, don't erase it, because if you make a mistake somewhere, I'll give you partial credit if I saw you started right. You counted it right to begin with. And just one line through it. Don't go scratching it out so I can't read it. Okay, number of oxygens, 2 times 2, that's 4. Okay. On this side, I now have 2 of these. Okay. And that gives me 1, 2. Sorry, hydrogens are the gray. 1, 2, 3, 4. I've got 4 of those. And now I look at my oxygens. And I've got 2 times 1, which is 2. And 2 here, which is 4. Okay? So when you put the coefficient up here, this is a huge, huge dilemma that people run into. If I put the coefficient here, I am multiplying only this O by the 2. I'm not multiplying all of the O's by 2. I see a lot of people put the 2 here and then think, oh, I doubled my entire amount of oxygens. No, you just doubled this oxygen. So go back and recount everything. It's almost like you put this stuff here, go back and recount everything again and double check it. And it's kind of like a puzzle. Some people have likened it to something that's Sudoku, which I'm not so great at, so I don't think it's like that. But that's what it is. It's kind of like a little logic problem. All right, let's go on to another one. Okay, N2H2 is going to form ammonia, NH3. So my non-metal that's not carbon, hydrogen, oxygen, and then H. Okay, I have 2 over here, and 2 of these over here. I have 1 and 3. So let's start with my nitrogens. I'm going to put 2 over here so I have the same amount of nitrogens. Pretty simple. I did that. But when I did that, 2 times N, 2 times the 1N, I also have now 2 times the 3 hydrogen, which makes it 6. You cannot change just one part of the molecule. Okay, you're putting a coefficient, and the coefficient is going to change everything. I know it makes it inconvenient, but that is just the way it goes. If you change just one of them, you have a totally different molecule there. It's like chemical reaction took place. We're not doing that. The chemical reaction is taking place throughout this whole thing, so you can't change subscripts. You can't put a coefficient in between. The coefficient goes in only one spot, right here. Okay, so now I have the right number of nitrogens on both sides. I don't have the right number of hydrogens, but that's easily resolved. If I look here, I have 2 hydrogens. What times 2 is going to get me to 6? If you said 3, you are correct. And that now gives me 6. All right, and I can use my little clone thing to show you that Oopsie poopsie. There we go. 1, 2, 3, and 6. Hold on. Alright, sorry, I just got a little cut off there, but this is your answer, and you'll see that the answer, hopefully it'll let me change it. Ta-da! There it is. Okay, I'm going to put another one up. I will go through the steps with you. Alright, so again, you look for your metals, no metals here. You look for non-metals that aren't carbon, hydrogen, or oxygen. You write those first. So I put P, and then hydrogen, carbon, hydrogen, oxygen in that order. I only have oxygen, so I put O, P, O. I count 4 on this side, and 2 oxygen on this side, 2 reactants, and 4 phosphorus in the product side, and 10 on the reactant side. All right, my phosphorus are good. Yay! But my oxygen are not. Boo. So what can I multiply times 2 to get 10? I hope you said 5, because that is the correct answer. Once I do that, I have 5 times 2, which is 10. Everything is the same on either side. And instead of actually showing you all the molecules, because I find that to be extraneous, I'm going to show you the answer. Ta-da! All right. I will do the setup, but I won't do the balancing for the next couple. All right, so let's go to the next one. Okay, so in this case, look for your metals. Metals first. We have one metal, iron, Fe. That's first. Okay. Non-metals that aren't carbon, hydrogen, and oxygen, not here. Carbon, hydrogen, and oxygen in that order. We have hydrogen, and we have oxygen. Okay. Count up your atoms on each side. Reactant side, 1, 2, and 1. Product side, 3, 2, and 4. All right, so my suggestion, start top to bottom. All right, see if you can balance it. Pause it, see if you can balance it, and then come back, and I will show you the correct answer. All right, and here's your correct answer. You would put a 3 in front of here, a 4 in front of here, and a 4 over here. And that would get you to where you need to go. Oxygen being the last thing, because a lot of times when you're balancing out the stuff above it, these things start to fall into place. Let's move on to another one. I'll do the same thing. All right, so here we go. Metals first, no metals. Non-metals that aren't carbon, hydrogen, oxygen, don't have them. Carbon, hydrogen, we don't have oxygen. Pretty simple. Count them out. 1 carbon, 2 hydrogen, 1 carbon, 4 hydrogen. Pretty easy one, I hope. Okay, see if you can get it. And you can pause. When you get back, here's your answer. Voila. I have a few examples, so I'll do a couple more. All right. Oh, crazy. Oh, my God. All right, let's go through this. Metals that aren't, or metals, I mean. So we go most metallic, or not most metallic. Sodium and calcium. It doesn't really matter which order you put them in. Sodium and calcium. Non-metals that aren't carbon, hydrogen, or oxygen. Sulfur. Oh, nope. I just cut something. SO4 on this side, SO4 on that side. They are both polyatomic ions, so I can put those like that. SO4. And keep it as one. And then chlorines. Okay? Count them up. 2, 1. Now there's only 1 SO4 here. And 2 chlorine. Okay? 1, 1, 1, 1. Okay? Pause it, give it a try, and come back to see the answer. Okay, here's the answer. It's just a 2. All right? I'm going to stop at that one. That's it. And I'm going to give you guys some practice on these. There's going to be a lot of practice because they get harder, and I'm going to keep challenging you. So I'll start simple, and then I'll get more and more difficult. All right? Good luck, and I'll see you in a bit.